Alright everyone, so in this example we have a 45 kilogram block that's dropped from a height of 12.3 meters onto a spring that's sitting at its natural equilibrium length, so its natural length. We want to find the velocity right before it hits the spring, the amount that the spring should be compressed when the block comes to a stop, and then we want to find the total energy of the system. So here we have a block falling onto a spring from a height of 12.3 meters. We can choose the top of the spring to be the point where the potential energy is equal to 0. So we can use the conservation of energy to solve all of the problems in this example. Remember that it starts from rest, you're just dropping it, so there's no initial kinetic energy. And when it hits the top of the spring, potential energy is 0. So we find that the final velocity right before it hits the spring is 15.53 meters per second. Now all of the kinetic energy that it has right as it hits the spring is going to be transferred into spring potential energy as the spring is compressed. So now what was the final situation in the last part is now the initial situation in the next part. So we have initial kinetic energy, final spring potential energy, as the spring is compressed and the block is brought to rest. And so here I realized that I had forgotten to put the spring constant in this problem. And so the spring constant's 1750 newtons per meter. And if you solve for the final compression of the spring, you find that it's compressed 2.49 meters. To find the total energy of the system, we can just use the initial potential energy and we find the initial potential energy is 5,424.3 joules. So the thing I want to point out here is that the spring is compressed 2.5 meters from a 45 kilogram block falling on it. We chose the 0 point for the potential energy to be at the spring. If that 45 kilogram block could still continue to fall 2.5 meters, then it's still going to have some potential energy associated with that position. In other words, because I chose the K value the way I did, just on the fly while I was working the problem, K is actually probably not big enough to catch this block in real life. So as you'll see in the next problem, if the length of the spring is known, then we have to account for the length of the spring as well. The only way that the 2.5 meters doesn't matter is if it's small compared to the size of the spring. And you're not going to find many 30-meter long springs that are catching what amounts to a 90-pound weight. So in real life, we'd have to account for that distance, and you'll see that in the next problem, how we do that.